Okay, so now we're going to find a recursive formula for this pattern. Again, the recursive formula is an expression for f of n in terms of the previous figure, or f of n minus 1. Okay? So here are the values, just n is whichever figure number it is, and then f of n is the number of squares in it. And so first we can check if it's geometric, all right? We can tell right away it doesn't have a common ratio. 8 divided by 1 is 8. 19 divided by 8 is not 8. It's 2 point something. 34 divided by 19 is not 8. Okay, so it's definitely not geometric. So let's look at the change, okay? Adding the change, so the change here from 1 to 8 is 7. Okay, from 8 to 19 is 11. And from 19 to 34 is 15. Okay? So we're kind of looking at this. And again, what this means is, I know where we're going with this, so I'm just going to cheat a little bit. What we're going with this is we're saying f of 2 equals f of 1. What do we do with it? We add 7, right? And then f of 3 is f of 2 plus 11. F of 4 is f of 3 plus 15. Okay? So we're trying to find what's a way of expressing this. It's different every time, but it does follow a pattern. You might notice already that what's the difference in these differences? Let's try and solve this pattern. Some people call this the second difference, or the change of the change. Okay, so 7 to 11, you add 4. 11 to 15, you add 4, okay. So if this sequence has a common difference of positive 4, we know this, linked with this, is an arithmetic sequence. Okay? So that means when we're trying to find these values, we need an explicit equation for this arithmetic sequence, or an explicit formula. Okay? So it's going to take the form of y equals mx plus b, right? Because it's an arithmetic sequence. We know the change is 4. Each step it adds 4. So however many x's, it's going to have those many changes of 4. And then now we're trying to find b. Okay? So my preferred method is that we have a combination. We know that for n equals 2, the change is going to be 7. For n equals 3, the change is going to be 11. I would choose one of these. So I'm going to try the easiest one. For n equals 2, the change is 7. So in this case, 7 equals 4 times 2 plus whatever b is. We're trying to solve for b. Okay, so 7 equals 8 plus b. That means b will have to be negative 1. Okay? So, let's test this out. Okay? F of 2. F of 2 is 8. F of 2 is 8 equals f of 1, 1 plus our formula 4. Excuse me, I'll rewrite this. Okay, 1 plus 4 times 2 minus 1. Okay, And this is true. 1 plus 8 minus 1. 1 plus 8 is 9, minus 1 is 8. Okay? F of 3. F of 3 is 19. F of 2 is 8 plus 4 times n is 3 minus 1. 8 plus 12 is 20, minus 1 is 19. Okay? So we can say for any n in this pattern, f of n equals the previous one plus 4 times n minus 1. And we got that by looking at the change, noticing the change, and finding an explicit equation for this sequence. For a quadratic sequence, the change is going to be an arithmetic sequence. And an arithmetic sequence is pretty straightforward for us to solve at this point.